In this video, I am going to discuss with you how to draw the differentiation graph that will be given for your A-level combined mathematics paper under question number 14, part A. For that, I have selected the question given in 2016 paper. The function is x minus 3 whole squared divided by x squared minus 1. For the first part, they want us to find the first derivative of this function. So that is f dash x. Since this is a division, we have to apply the differentiation of a division. That is, first writing the denominator as it is and have to differentiate the numerator. It's 2 times x minus 3 and again the differentiation of the function. Differentiation of this function is 1 minus, then write the numerator as it is, then differentiate the denominator. Differentiation of x squared is 2x, minus 1 is 0, then whole thing divided by square of the denominator. Now we have to simplify this. From these two terms you can see 2x minus 3 is a common factor. Take 2x minus 3 common factor out and we are left with x squared minus 1. Here when we take 2 out, we have x and x minus 3 term. Denominator. Then simplify this method. X squared minus 1. When we open the bracket, we have minus x squared plus 3x. Plus x squared minus x squared get cancelled. Then the factors are 3x minus 1 divided by x squared minus 1 whole square. So this is the first derivative. So this is the first part of the question. After that, we have to identify the asymptotes and turning points of the function. Asymptote is a point, asymptote is a value of x where the function y equals fx is not defined. So what are the values where the function is not defined? This fx function is not defined when the denominator becomes 0. For that you have to make this denominator 0. That means equate the denominator to 0 and find what are the values of x. So you can find it. X squared minus 1 equals 0. Answer is x equals plus or minus 1. So we can write when x equals 1 and x equals minus 1, f of x is not defined. Therefore, x equal 1 and x equal minus 1 are vertical asymptotes. Then we have to identify the turning points. For that, we have to equate our derivative f dash x to 0. So this is the condition for turning points. This is the first derivative. Equate it to 0. From that, you can see x minus 3 into 3x minus 1 becomes 0. That is, x equal 3, 1 root, or x equals 1/3, second root. Therefore, x equal 3 and x equal 1/3 are the turning points. Now we have already found the vertical asymptotes and turning points. So these two are the vertical asymptotes and these two are the turning points. Then we have to prepare a table to identify the nature of the gradients. For that, first I will arrange these four numbers in order. First one should be x equals -1. Next one should be x equals 3. Next one x equals 1. X equals 3. Then the range before this is x less than -1. Here it is between -1 and 1/3. Between 1/3 and 1. Here it is between 1 and 3. This is greater than 3. These are the ranges. Then we have to separate the asymptotes and turning points. So we have two asymptotes, +1 and -1. So this is an asymptote, put dotted line, +1. This is also an asymptote. X equal 3 and 1/3, they are stationary points or turning points. Therefore, their gradient must be 0. Now we have to identify the nature of the gradients in these ranges. For that, take the convenient number according to the range and substitute that value for f dash x, not f of x, because here we are going to identify the nature of the gradient. So gradient is denoted by the derivative of our function. So we have to substitute this value for f dash x, not fx. So let's consider this range. X is less than -1. So you can take -2. So substitute -2 in terms of instead of x. So this bracket, when x is -2, will give you a negative answer. And this bracket is negative. Then this one, 3 into -2 is -6. -6 -1, again a negative answer. So no need to consider this denominator. Why? This entire denominator is squared. So if you get a minus answer, when it is squared, it becomes positive. If you have a positive answer, when you square it, it is also positive. So always we are getting a positive answer from the denominator. So for the rest of this part, no need to consider this. So minus into minus from these two brackets will give you plus. So plus means we have the gradient in this shape, which is increasing. Gradient is increasing. You have to write these 3 steps. Now substitute a number within this range. So we can take 0. So when I substitute 0, this bracket gives you minus answer. This bracket gives you another minus answer. Minus into minus. Yeah. So this is increasing. Now x is between 1/3 and 1. So 1/3 is 0.3, close to 0.3. So I have to substitute a number between this range. So I can use plus 0.5. So when x is 0.5, again this bracket gives you minus. 3 into 0.5 is 1.5. 1.5 minus 1, it is plus. So this bracket gives you a positive answer. Minus into plus, this is minus. So for the first time we are getting a decrease in gradient. So this part is decreasing. From this range, we can say we can take x as 2. So when I substitute x equal to here, this bracket gives you minus 1, it is minus. 3 times 2 is 6, 6 minus 1 is plus. So minus into plus, it is minus. So this is decreasing pattern. In this range, x greater than 3, so I can substitute x equal 5. 5 minus 3 positive, 3 into 5, 15. 15 minus 1, that is also positive. Plus into plus will give you plus. Increasing. So likewise, when you have asymptotes and turning points, you have to arrange them in ascending order and indicate asymptotes like this, dotted lines. Then mark 0 for turning points and take f dash x and substitute a convenient x value for the range you are selecting and check whether the answer you are getting is positive or negative. If it is positive, it is increasing gradient. If it is negative, it is decreasing gradient. Now, from these locations, you can see the gradient is increasing and becoming 0 and decreasing. That means this particular point is a maximum. Here we have decreasing, becoming 0 and increasing. That is, here we have a minimum point. Now I have to find what is the coordinate of this maximum point, coordinate of this minimum point. For that, I have to substitute x equals 1/3 for our function. So we are using this derivative f dash x only to find the nature of the gradient. After that, no need to consider this. For the other parts of the graph, we have to consider f of x. Now, to find this turning point, I have to substitute 1/3. So when x equals 1/3, what will happen to the function? Function is x minus 3 square. 1/3 minus 3 square divided by x squared minus 1. That is 1/3 square minus 1. Now simplify. This is minus 8 over 3 square. Here we have 1 over 9 minus 1. Minus 8 square is 64 over 3 square is 9. Here we have minus 8 over 9. 9 cancel. 8 times 1, 8 times 8. So f of 1/3 is minus 8. So I have the coordinate. What is it? When x equals 1/3, y becomes minus 8. Therefore, 1/3 comma minus 8 is the maximum point. So this windlass is a local maximum. Now let us find the coordinate of our minimum point. So we know minimum point is obtained at x equals 3. So f of 3 is 3 minus 3. That becomes c. So no need to go further. When we substitute 3 here, we get the answer as c. Therefore, coordinate is 3, 0 is a local minimum. So at 0 we got the local minimum. At minus 8 we got local maximum. We have to find the other asymptote. Earlier we found vertical asymptote. Now in our graph we must have a horizontal asymptote. So what is a horizontal asymptote? Horizontal asymptote is what our function is approaching when our x value tends positive infinity as well as negative infinity. When the function is moving to an end, it will reach to 0 if horizontal asymptote of the function is 0. If it is 3, that means the function is reaching y equals 3 lie at these two ends. The function will have a minimum point like this, and it is intersecting x-axis at 1, y-axis at -1, and approaches y equals 3 at these two ends. So this is the form. So similarly, for our function as well, we have to find this horizontal asymptote, whether it is 3 or 0 or any other negative answer. So how to find it? For that, we have to take the limit of our function. The x tends plus or minus infinity. So our function is x minus 3 squared over x squared minus 1. So when you have these kind of expressions to find limits, first you have to expand them. So this gives you x squared minus 6x plus 9 divided by x squared minus 1. From these two, you can see the highest degree for these two functions is 2, that is x squared. That means you have to divide both numerator and denominator by the highest degree of x term, x squared. So when you divide these terms, you get 1 minus 6 over x plus 9 over x squared. Here you have 1 minus 1 over x squared. So when you substitute infinity for x, you can see all these terms become 0. We are left with 1 and 1 in denominator. So 1 divided by 1 is 1. After finding horizontal asymptote, we have to find the intercepts, x-intercepts and y-intercepts. To find y-intercepts, we have to find the value of the function when x equals 0. When x equals 0, we can find where the function is intersecting in y-axis. That is f of 0. This is our function. That is 0 minus 3 squared, that is 9 over 0 squared minus 1. So we get minus 9. That means 0 minus 9 is the y-intercept. Now we have to find the x-intercept. For that, I have to substitute 0 for y. X minus 3 squared divided by x squared minus 1 equals 0. Here we have x minus 3 squared equals 0. From this, I can find the value of x, that is 3. Therefore, 3 comma, what is the y value? 0. 3 comma 0 is the x-intercept. Now we have two intercepts, horizontal asymptote, vertical asymptotes, and coordinates of the turning points. Now we can draw the differentiation graph. First, you have to mark the two vertical asymptotes. They are x equal minus 1, somewhere here, then x equal plus 1. Secondly, you have to indicate the two turning points. We have a maximum point when x equal 1/3 and y is minus 8. 1/3, somewhere here. Y value is minus 8. This is a maximum point. Put a mark like this. Then you have the minimum point at x equal 3, somewhere here, y is 0. That is 3 comma 0. This is a minimum, like this. Then we have the nature. The two gradients are increasing when it is less than 1/3 this side, and this side you have a decreasing gradient, and the two asymptotes are -1 and 1. That means this graph must move like this. That means when y value moves to -infinity, they are approaching -1 and +1 from both sides. And here we have a minimum point which should move towards, it is moving towards +infinity when it reaches +1. Temperature must be touches x-axis at 3. So we don't know what is the nature of the graph when it is beyond 3 and beyond -1. So that is identified from these two ranges. Here we have when x is greater than 3, the gradient is positive, that is increasing, but it is increasing to a certain value. We have calculated the horizontal asymptote as 1. We found limits of the function when x tends plus or minus infinity. That means when x tends plus infinity, graph the function is moving towards 1. Function is moving like that way. When x value tends minus infinity, again it is moving towards 1. Less than -1, we have the gradient, it is increasing. That means we must have a line like this outside. From that, since the gradient is positive, increasing gradient, I can draw the line in this manner. Approaches 1 when it tends to minus infinity, and it approaches plus infinity along y-axis when it approaches -1. Then what are these 2 points? These are intercepts. This is the y-intercept. So we got the y-intercept as 0 -1. So this is -0 -9. So this is our y-intercept -9, and x-intercept was 3, 0. So this is the x-intercept. So this is the final answer. So when the function is given, first you have to take the derivative, then you have to identify what are the vertical asymptotes, then you have to construct this table. For this table you have to use the first derivative you got. After that you have to find this horizontal asymptote by finding limits. To find the horizontal asymptote, you have to take the limit of the function when x tends plus or minus infinity. After that you have to identify these intercepts. To find the y-intercept, substitute x equals 0. To find x-intercept, substitute y equals 0. By taking all those coordinates and nature of the gradients, you can draw this graph. Thank you.